We are Team Delta, and our project is Drive by Age. So as a driver, and especially a young driver, it's incredibly important to be aware of the road around you, and in particular the limitations of other road users. However, youth cannot know how age thinks and feels, and young people often don't understand that an older person can have very different reaction times, decision-making abilities, and vision quality to them. And this is where our project comes in. So our goal was to create a driving simulator which would show the world through the eyes of someone experiencing many of the vision problems currently associated with old age. We want to encourage people with normal vision to understand the visual difficulties other drivers may face and take more precautionary measures on the road because of this. So a full-blown driving simulator was a bit out of scope of the project. Instead, we created a drop-down of Google Street View, and image processing is applied to simulate various vision problems common in the elderly. Drive by Age lets the user choose their route using a keyboard and works in the UK and many other locations around the world. We split our project design up into distinct modules. So the route planner component fetches location data from OpenStreetMap, and it works out the orientation of the road and any connecting junctions. And the image fetcher fetches the corresponding Google Street View images, and the image processor applies the vision filters to the degree specified by the user. So the problems we simulate are long and short-sightedness, loss of peripheral vision, and double vision. The driving engine ties these components together and feeds the resulting data to the UI, which signals the driving engine when the user is ready to advance to the next frame. The engine also implements a cache, which dramatically improves the responsiveness of the system. So we use a simple Gaussian blur to simulate short-sightedness and long-sightedness. And in this screenshot, you can see how junction decisions are displayed in the UI. You can cycle through the arrows and select the road you want to go down. Double vision or ghosting can occur in old age as a result of cataracts or corneal disease. And we simulate it by overlaying a stretched, translucent version of the original image. Night mode is created by reducing the image's contrast and blending it with a dark blue overlay. The screenshot also contains very bright headlights, which appear in about 30% of nighttime images to demonstrate the increased sensitivity to glare, which can occur in the elderly. For example, if someone drives towards you with their fog lights on. And we simulate peripheral vision loss by overlaying a translucent circular mask to darken the image at the edges. We encountered several technical difficulties during this project. The most serious were the limitations of the OpenStreetMap API, which sometimes gave us unreliable data and didn't always sync up perfectly with Google Street View's location information. We also initially had problems with latency, since both the route planner and the image fetcher required use of the network. The most effective strategy we found was using an OpenStreetMap server in France rather than the default in Germany, which halved the route planner's network time. And where could this project go in the future? Well, Google have developed a system which generates smooth video from distinct Google Street Map type images. Unfortunately, it's quite slow at the moment. It takes 12 minutes to process each frame. But if this was speeded up, this could be a way of creating an actual driving simulator from this project. I'd like to thank the whole team for their hard work on this project, and also Dana for her support and understanding. Thank you very much.